going to hand over to our first speaker, who is Patrick. Patrick, do you want to take it away?
Yeah, sure. Hi, everybody. I will just start this. Okay, great. So my name is Patrick Chwalek, and I'm here to present a multimodal acoustic monitoring system that I designed for bee conservation. And so just broadly, I am a PhD candidate at the MIT Media Lab in Cambridge, Massachusetts. And my research focuses on system design. So I make systems both for humans, so wearables like smart glasses with a lot of environmental sensors, but also wearables for dogs, both domestic and wild, and then also with different types of environmental sensors that we distribute throughout a landscape. And so a lot of the work that I've done over the last 2 years has been focused around National Geographic Explorers. I interned with them a few years ago, and we've been collaborating ever since. So a few of my projects these days are with explorers. Two in particular are with one's with dogs, and then the one that I'll be talking about today is with bees. So the work, starts with this guy. So this is the Bombus dalbami. It's one of the world's largest bee species. They are native to South America. They're colloquially called the flying mice, and in the UK, they're actually called the monstrous flying ginger beast. Um, and to track these guys, well, actually, one quick backstory. So these bees are native to South America, but the issue is they are endangered because the importation of foreign bees. So right now, in Santiago and also in Argentina, they've been importing foreign bees for the last 30 years. And the biggest importation is of the European bumblebee. And that's specifically to help pollinate cash crops that they're growing in the region. The issue is we don't really know how the native bumblebee populations are being impacted by this importation, and with global warming, and that's becoming a bit harder for the local bees. But the European bees are actually thriving in that kind of climate. And another issue is that a lot of these areas where these bees are native are very remote. So the gold standard is a person goes out to this remote region, sits there for a couple days, and records on a pen and paper when they see a bee and what type it is. And so we're trying to automate that approach. So to do that, I designed this acoustic monitoring system. It's a distributed microphone system where we built from the ground up here at MIT. It has two stereo microphones that have been calibrated to reduce electrical noise and to really get the highest fidelity acoustic signature of the landscape. And we've also calibrated the whole housing in a wind tunnel to reduce any kind of wind noise on the microphone diaphragms. What the system also has is a series of other sensors, such as temperature, humidity, gas, because and gas is a proxy for how well ventilated an area is, so airflow. And that's because if you're trying to build a model based on the acoustic data, it's really important also to have some idea of the local environment because bees won't fly when it's too cold. They start hibernating. They also won't fly if it's too windy or if it's raining. So having some knowledge of these priors is important if the end goal is to build a model. And that's exactly what we're trying to do with the data that we've collected, is to build a model that will run on these systems that then you could scatter throughout a landscape, come back in a few weeks or months, get them, and then you have some idea of bee buzz density and species for any given area. And most recently, we did a pretty large deployment. So I built 10 of these devices along with other things like audio, MOS, and 360-degree cameras. And I partnered with a team, so Marina Arbitman out of Bariloche, and Christian, who's out of Santiago. So Marina is a bee expert. Christian is an insect expert. And their students, Josefina and Vicky. And we went down to Puerto Blest, Argentina, which is a remote region just in the center of Argentina on the Chilean border. And so you fly into Bariloche, then you take a ferry an hour to Puerto Blest. It's a very remote region, and it's ideal for capturing wildlife recordings. And so we distributed a few of these sensors near local fuchsia bushes where these bees like to frequent. And we collected data over 6 days. We also designed an iPhone application that connects to individual sensors and allows you to quickly annotate on the fly. So we got rid of the pen and paper, and now you just have to click a button when you see a native or invasive, or you could create a new button on the fly or add some observations. But this allows us to synchronize the observations with the acoustic data so that in post-processing, you already have all the data nicely and neatly organized. And it also records a bunch of other environmental readings as well. And so we distributed these sensors for 6 days across the landscape. And a subset of that time, we had human observers in the area annotating. And just to kind of get some perspective, so this is what the terrestrial invasive bee species sounds like. And this is what the Dalbami sounds like. Oops. So they sound a bit different. Dalbami is a bit deeper, it sounds a bit more muscular, but this kind of points to the fact that we could create a model that could differentiate between the two based on just the acoustic signatures. So now we have this whole data repository, which we're working on publishing, and then also building models in-house at MIT that will hopefully run on device later this year. And that's it. So hopefully, and so hopefully I kept to time. And if you have any questions, or if there's time for questions.
Awesome. That's so interesting. I have one question. If you could hear from anyone today, or like if anyone could contact you, who would you want to hear from?
Yeah, anyone that would find these systems useful. So there's a lot of different audio recorders used for similar applications. Most of the time, it's in areas where it's hard to procure the latest and greatest because you have financial or logistical restrictions. And so oftentimes you use like a cheap microphone recorder. Those are great. The problem is they're not as great if you're trying to build like a model that's trying to learn on the intricate frequency patterns of different species. And so if anybody would find any value in using a system like this, I'd love to hear from you and kind of how you would use it. And that will kind of help me build the next version of it, which I'm currently working on to do a new version by spring of next year.
Awesome. Okay, ping Patrick in the chat, or if you're watching this afterwards, there will be a link to a thread on WILDLABS. I'm pretty sure you have a thread on WILDLABS to chat with you directly.
Yes.
Perfect. Okay, thank you very much, Patrick.